Welcome back to the second video in the series on software, and we're going to continue with our discussion of system software. So let's talk about a few of the most popular operating systems in use today. The most popular of all and the most common one found on a modern computer would be one of the versions of Windows. The current version is Windows 8. This product is produced by Microsoft and, as you know, is the one featured in this course. We have been or will be covering Windows 8 in some detail with our hands-on exercises. Even before the first microcomputers were built, there was a general-purpose operating system called Unix that today is also available for a PC. There are also several versions of Unix, including several renditions of its most popular version, Linux. There's Ubuntu Linux, SUSE Linux by Novell, Red Hat Linux by Red Hat, and several more. In fact, another very popular operating system that's based on Linux is the Mac OS, found on your modern Apple computer. Linux is referred to as an open source software product, meaning that the source code is available with the product so that a knowledgeable user can actually make modifications to it. Often, open source products are available at no charge. Now let's move on to the next category of system software, the translators. In lectures throughout the course, we talk about how computers only use binary to execute instructions. In fact, in this very online section, during the binary video, we'll discuss how switches are used to implement ASCII code with binary. When we look at a string of binary digits, we quickly grasp how difficult it would be for a human being to try and program with nothing but zeros and ones. It would be impossible. The computer manufacturers provide a primitive language with their products that can be used to write instructions. This language is called assembly language or machine language. Even though writing programs in assembly language would be much easier than coding in binary, it is still very difficult, and with that language alone, programming would be very, very tedious and slow. So over the years, a number of excellent higher-level programming languages have evolved to make the task of writing programs much easier and more efficient. These are languages like Fortran, COBOL, C, Ada, BASIC, and more. Let's not forget, though, that when it comes right down to it, the computer only speaks binary. The manufacturer has given us assembly language to help, but nevertheless it's reasonable to state that computers cannot speak any language but binary. So how do these high-level languages work? There are two broad categories of these languages: interpretive and compiled. Just a few minutes ago, we talked about IBM having a contract with Microsoft to create the BASIC interpreter for their new IBM PC. BASIC is an interpretive language. C is a compiled language. We accept that since the computer only speaks binary or assembly at best, these programs written in a higher level language will have to be translated in order to be used. An interpretive language like BASIC uses a utility called an interpreter to convert the higher level language into machine language one line at a time as it runs. Remember, interpreters translate the code one line at a time. Compiled languages use a utility called a compiler to convert the entire program at once and then write the code to a new file. So the interpreters like BASIC translate one line at a time as the program runs. Compilers for languages like C will convert the entire program into machine language and then write that program to a new file that can be run without having to interpret each line as it goes. Now let's look over our third category of system software. Utilities. There are many housekeeping chores, so to speak, that must be done on a computer. When one installs a new disk drive that has never been set up for use or cleans off an old one for reuse, a utility called format is needed. When the operating system prepares a disk drive for storing programs and data, it must first create a table for keeping up with bad tracks and then test each storage location and records its state, good or bad, in that table. As one uses the computer, the operating system stores data to the disk, and in order to do that, must first check a couple of other tables that were created during the formatting process to see what memory locations are free, stores the file in as many locations as necessary, and then records in even another table the file's name and other information about the file. Format is a utility for handling the chores of testing the disk and creating those tables. As the computer is used over time, the disk storage sometimes becomes fragmented. By this I mean that as files of different sizes are added and deleted, the available storage locations become fragmented, meaning that instead of one large chunk of available space, the available space becomes separated, making storing and retrieving data inefficient as the drive starts filling up. A utility called defrag reorganizes the drive by moving files around to create one large chunk of available storage, thus streamlining the process of storing and retrieving. The File Explorer that we have studied or will study is another example of an operating system utility. There are a great many of these utilities that an experienced user may employ from time to time. Here we see a graphic showing a computer and the devices it manages. The computer contains the microprocessor, RAM or primary memory, and various other components that help to manage all of these devices. Not all of these things were actually managed by those early micro operating systems that we discussed earlier. For example, the printer had to be controlled by the application program back then. But today, a modern operating system takes care of them all. It knows how to make that printer eject a page, or print in boldface, or underline, and so on. It is able to turn on each pixel of that monitor. As we just discussed, it knows where the tables are on this drive and how many tracks it has and where they are. In Windows, this information is provided to the operating system by drivers that are installed when we get the printer. In fact, each of these devices have drivers provided by the manufacturer. As a result, the operating system is able to assist the application programs and the users to make use of all this equipment. So there we have our discussion of system software, the software that manages the resources on the computer. Let's take another short break. Look over your notes pertaining to the information we just discussed in this one, and when you're ready, come on back and we'll proceed to application software.